Welcome, everybody, to the School of Science, the virtual School of Science, because this is, in the pandemic period, and we're going to talk about what we're doing during that time, what we've been doing in terms of teaching, what we've been doing in terms of research, and give you a real good feeling about what we're up to around here. We're so glad you could join us for this, because I'd love to be able to be there and shake your hands, but this is about as close as we're going to come right now. But for now, I just wanted to tell you a few things about what we've been doing, for example, in terms of pedagogy and what we've been doing in recent history here. Well, some of you may remember we had what we called the spring pivot, which was something where we changed over to online instruction in the middle of last spring. We're celebrating, quote unquote, the anniversary of that right now. We learned from that. We did a great arch summer. We learned from that. And then we did a great fall. And right now we're in the middle of spring, and we're looking forward to, by the way, getting back together in person in the near future at some point as a result of the applied science of vaccines. And so you'll find science everywhere, and that's just one of the things I always see. So I wanted to talk about what we've been up to in several different areas, but one of the first ones is what I call societal resilience. Now, societal resilience is actually a lot of different things. It's, how do you keep the lights on? How do you keep society running? What about communication? What about veracity of communication? In other words, who do you trust and how? And how do we understand that? Well, science applies to all of those things. So let me just tell you about one thing that's going on in that area. There's something called computational trust, where there's a way to actually use artificial intelligence to determine what the likely source of information is in terms of its veracity or truth. That's another thing you'll find out about if you visit us on our landing site, which we're going to have for the School of Science. Now, I also want to talk to you about some things. Well, astrobiology, for example. We have the Rensselaer Astrobiology Research and Education Center. It's one of our newest things. It's not just in the School of Science, but this center focuses on the origins of extreme life, the conditions under which extreme life can exist. And by the way, this is very relevant to the signatures of potential life that the Perseverance rover is looking for on Mars right now. That's an exciting thing. We've had a connection with these missions, the last one and this one as well. And our connection with space goes all the way back to the Apollo program. And George Low, who ran that, was in fact a Rensselaer president right after he got done with all of the Apollo missions. Let me tell you also about dark matter. Dark matter is something that we're exploring and looking for throughout our physics department. We have a group of people looking into that. Very exciting stuff. We're also looking at COVID. Now, that's something you're going to be hearing about, and I'm sure you've heard about an awful lot lately. And we're looking at that in two different ways. One, we've applied some of our most high-power computing capacity at Rensselaer to modeling COVID and how the outbreak is moving, how we can minimize the impact on campus, and we can look at changing different things and make predictions about how it'll affect the likely number of cases. And we've actually used that and shared that with other institutions to try to minimize the impact of COVID. We also have folks doing research in more generic antivirals. In other words, how do we prevent the next one of these pandemics from developing without having to develop a specific virus, antivirus rather? We're going to be telling you a little about that too. Now, let me talk to you a little bit about for example, heparin. One of the faculty in our school has developed a synthetic heparin that basically is used in a tremendous number of things. The real life heparin is. The synthetic heparin doesn't have supply chain questions about it, which has happened in the past. And so let me just say that what we're doing there and a variety of other things, including environmental science, what we call the Jefferson Project, which has to do with modeling the food web at Lake George and how basically who eats who and why the lake stays in good shape and how we can help it remain that way. it's a big project that involves a lot of technology that we have, for example, in edge computing, machine learning, collaborative tools, and a great interaction and collaboration we have with two of our partners, IBM and the Fund for Lake George. We're going to talk a lot more about that, and there's going to be some links on our landing page for the Virtual Homecoming and Reunion 2021, and I invite you to take part in that, to poke around and look at it, explore our links, and then ask me any questions you want. You'll be able to find me at Rensselaer, and I love to tell people more about details. So I'm Kurt Breneman, Dean of the School of Science, and I'm really glad you joined us. Thank you.